It's a common misconception that people have that if you have a complete spinal cord injury, it means that the spinal cord has been completely severed, like as though you took a knife and cut it. But the vast majority of spinal cord injuries that are even complete, the spinal cord, if you look at it with the naked eye, would look pretty normal to us. The damage to spinal cords, whether or not it's complete or incomplete, is really primarily at a microscopic level. So what one has is initially an inflammatory response with edema or swelling of that area of the spinal cord, and as a result of that inflammation and swelling, one can then have cell death and hemorrhage. Just like you have a bruise in your arm, you'd have a bruise in your spinal cord. And that's what kills the cells and causes the spinal cord damage. If we could look inside the spinal cord and see the tracks that go up and down and that basically connect our brain to our feet. So if we say, I want to move my foot, a message starts in my brain, sends a message down the spinal cord, then through a nerve, and then to my leg muscle to move. That's how we usually would move something. Opposite is by feeling. We would stimulate a nerve fiber in our foot, for instance, sends a message up via nerve, our spinal cord up to our brain. With a spinal cord injury, those transmissions are either completely stopped or partially stopped. And so if you have a complete lesion, theoretically, the vast majority, if not all, those tracks that are going up and down have been damaged one way or another. The truth is that probably even in complete lesions, there may be a few fibers that are still running up and down, but they're not enough for you to be able to voluntarily move your leg or to have sensation. The other thing that happens, in addition to loss of fibers, is we lose something called myelin. And myelin is an insulation that our nerve fibers have. It's kind of like any kind of electric cord. That the way electricity flows is you have to have a insulation so the electricity goes in one direction, doesn't kind of dissipate all over the place. So we have something called myelin around our nerve fibers, or axons, that help transmit our messages from one place to another. So after a spinal cord injury, for many reasons, these axons lose their myelin or their insulation, and even if there exists, the transmission is slow or very poor. Clearly, spinal cord injuries, if they're complete, have major impact on one's gross motor function. On the other hand, there's all different extremes of incomplete spinal cord injuries, to having sensory preservation, to those who have some motor abilities to almost to normal.